Hello, everyone, and welcome to our latest DZone webinar. My name is Jason Cockrum, and I'm the Community Engagement Manager here at DZone, and we're glad you're with us. We've got a really relevant and exciting topic for you today, so we're excited that you're here. If you're new to DZone, we are one of the world's largest online communities of software developers and experts, and we publish all sorts of knowledge resources for developers and anyone passionate about software development, with everything from ref cards to trend reports and thousands of articles written and published by our community. We are the go-to knowledge hub for software developers all over the world. Joining me today, we have Julius Volz and George Hamilton. Julius co-founded the Prometheus monitoring system and originally led the project to success at SoundCloud and beyond. And he now focuses on growing the Prometheus community and helping companies use and adapt Prometheus through his company, Prom Labs. Before creating Prometheus at SoundCloud, he spent some time as a site reliability engineer at a small, little-known company called Google. George is the director of product marketing at Chronosphere. He spent over 25 years in the technology industry and has held many product marketing roles at leading global tech companies such as Cloud Health by VMware, Zabia Labs, Digital.ai, and Dell EMC. He's also spent some time as an industry analyst covering IT systems management and application performance monitoring. So real quick, a little bit about Prometheus. It's a powerful metrics-based monitoring system for the cloud-native world. So those cloud-native systems and applications and things like that, Prometheus provides monitoring for those systems. Our topic today is about playing with fire. And while Prometheus is a powerful tool that allows flexible monitoring of systems and infrastructure, there are some potential pitfalls that if you're not aware of, you'll end up playing with fire that can really consume your engineers and your apps and just eat up your time and costs and resources and add unnecessary risk and all those bad things that we try to avoid, right? So today, Julius is going to talk about some of those pitfalls and provide some of the most important best practices to avoid getting burned and getting the most from your native monitoring systems. And then George is going to walk through how Chronosphere's cloud-native observability platform helps you to quickly implement those best practices. They're going to talk for a few minutes, then I'm going to jump back in towards the end and we'll answer some questions. DZone is all about community, so we encourage you to get involved and get engaged in the conversation. On the right side of your screen, there's a box where you can chat with other attendees and discuss what's being talked about. And there's also a box where you can submit questions, and so we'll do our best to answer as many of them as we can. At this point, I'm going to go ahead and hand it off to Julius. Julius, take it away.
Thank you, Jason. Great introduction. So first of all, thank you to DZone, thank you to Chronosphere for making this happen. Very glad to be here. So yes, this talk is geared towards people who are just starting out with Prometheus or semi-intermediate advanced, but not really experts. Basically, I want to give you a wide variety of little tips and best practices around avoiding the worst things that can happen to you in the Prometheus field. So, in Greek mythology, Prometheus was a titan who stole the fire from the gods and brought it to the humans. The humans really liked that, but the gods were not too happy, and they tied Prometheus to a rock for all of eternity. And then every day an eagle would come, would eat the liver, and the liver would regrow, and the same thing would happen again the next day. And it's somewhat similar with Prometheus-based monitoring. On some days, you feel like in the left picture where everything is happy and illuminated. And on other days when stuff goes wrong, you feel more like in the second picture. And this talk basically is about making you feel more on the left side here. So we're going to cover a couple of areas. First of all, what to watch out for when you are getting metrics out of all your systems and devices that you are instrumenting. Then once you have that data collected, how do you properly alert on that? Then in general, whether it's for alerting or other purposes, what do you want to watch out for when writing queries? And then going kind of to the architecture diagram and the boxes in that of your monitoring, like what are some things that you might want to watch out there? All right, let's talk about instrumentation first. So a couple of general points first, right? If you have never ever instrumented anything, these are good rules of thumbs for what kinds of metrics to even put into a system that you want to monitor and that you want to measure. There's two rules of thumbs. One is the use method coined by Brendan Gregg, famous observability guy, and the red method by Tom Wilkie for two different types of systems. So if you have a system or a resource, like something that looks like a resource that can be either completely unused or 100% used, then this method applies. So you typically want to track the utilization, right? Something between 0 and 100%. Saturation, how much additional work is there waiting to be done that currently cannot be serviced, like tasks that want to run but can't because the CPU is busy, and any errors that occur. So these are just general guidelines in that situation. Now, if you have something that is more of a request serving system, like a database, an API server, or so on, you want the red method, which just says you want to track the total number of requests that are happening, the error rates that are happening, and also the latency distributions or the durations, right? I have so and so many requests that are really slow and so many that are really fast, and getting kind of an idea of how that is distributed. A little bit more Prometheus specifically, when you have metrics in Prometheus that are not split up dimensionally by a label, they're super cheap. So I would recommend spreading metrics very liberal across your code base everywhere. So think about everywhere where you typically previously would have had a log line, like some error occurring or so. It's a good place to put a counter metric saying like this particular error occurred right now once, and then you can track rates of that and so on. Also, try to not only instrument your application code itself, but also common shared libraries that you're using in your organization. That way you can just use that library everywhere, pass in a way to register metrics, and then automatically get all these, let's say, gRPC metrics or similar things, right? Without having to redo that in every application. Getting even more Prometheus specific now, the metrics that you instrument in Prometheus, that you put in your services for them to emit to Prometheus, have a name. And these metric names are not semantically interpreted in any way by the Prometheus server itself. But they're important for humans. Like if you see a metric name, you want to be able to quickly interpret what it means and what it's about, where it's coming from. So you see a link down here that has a pretty elaborate list of best practices for how to choose metric names and the labels on them. But just a couple of quick points here. Try to always put a unit in there when a unit makes sense as a suffix in the metric name. And keep these units as base units. So use seconds rather than milliseconds, use bytes rather than kilobytes or megabytes, and so on. This really helps when you have many different types of metrics. You want to quickly graph some, you want to combine them arithmetically or in different ways. And then you don't have to think about like, which unit is this in? Do I need to convert it first? And so on. If everything's in base units, that just simplifies things. Also, there are situations where it wouldn't be clear otherwise whether a metric is a gauge, which is like a current total tally or count of something, versus a counter, which is a cumulative count of things that have happened over all of time. And so we have this convention here to add an underscore total suffix to every counter metric that you manually create. Also, often there's the question of which time series do I put into one metric name versus, omitting it completely or putting it into a different metric name. And the rule of thumb there is it should either make sense to sum or to average over all of the time series within one metric name, right? That should be a meaningful thing in the usual case. So for example, if I have a bunch of CPU usages and they are split up by the different usage modes, idle, system, user, and so on, then I can sum over all of those usages and I will get back something meaningful. In this case, it would be the number of cores if I use the rate function. Now, if I have different example, memory usages that are partially overlapping, especially if you have usage type equals total in there, if you summed over all of those, those wouldn't make sense anymore, right? Because it's not something, the labels are not completely partitioning the available space of meaning within that metric name. So in that case, that you know, wouldn't at least make so much sense. Okay, so another common beginner thing is that you discover labels when you're first starting to use Prometheus, and you notice that they're really useful. And you might track things like HTTP request counts. You split them up with a label called method to kind of get separate counters for post, get, put, delete methods, and so on. That's fine. But maybe the next day, you know, someone new to Prometheus has the idea to also track the user ID where a request came from. And now you have millions of users. And what happens is that basically, you know, every possible value of that user ID label gets multiplied with all the other possible labels on this metric. And you end up having, you know, just because you have so many users, you end up having like millions and millions of time series. And most assuredly, your Prometheus server is going boom or OOM out of memory. That's a common thing to happen. And so, you know, you just have to keep in mind that every unique set of labels generates automatically one time series the first time Prometheus ingests it. There's no schema or so, it just happens. And so you want to try to, you know, not put unbounded values into labels. So these would be public IP addresses, user IDs, full paths in HTTP. So we did this at SoundCloud. Someone accidentally put a full HTTP path into a counter metric, and the HTTP path contained the SoundCloud track ID. And there were 100 million tracks. So this immediately also blew up Prometheus. So in general, like, try to keep your label values well bounded within some reasonable set of values. Think about the fact that all these different label cardinalities multiply together. So if you have a metric that has 2 labels, and each of these 2 labels has 10 potential different values, and they can happen in all combinations, then you will have 100 time series resulting from that alone. Ultimately, there's not a higher, like, official upper bound for how many values you can have in one label or so, but what ultimately matters is just how much can your Prometheus server handle. Typically, a big Prometheus server that has, you know, many gigabytes of RAM is happy doing a couple of million of time series. There's also larger ones that do more. That's the ingestion side budget, so to say. But then you also have to think of, I want to usually be able to comfortably query all the time series belonging to one metric name, at least in a tabular view, so I can see what time series belong to this metric name. And that is still possible up to like tens of thousands of metrics, right? But above that, it gets a little bit excessive. So keep that in mind as well when designing labels and the metrics they're on and so on. So in general, like, we want to look at the metrics you're exposing, the kind of multiplicative labels on them, and then also the number of targets that expose these metrics, right? Because that is another multiplier. And that all multiplied together needs to stay under these total budgets. If you have situations in your code where you want to track an operation that can very binarily either succeed or fail, a common first step would be to, you know, create one counter that tracks the number of errors and another counter that tracks successes, right? These 2 possible outcomes. Now, seems good, but actually, if you look at the most common operation you will want to do in PromQL afterwards with this, is you want to have a ratio between the errors that are happening and the total rate and not the successes, right? And so if you want to achieve that, then your PromQL now becomes a little bit more complex. As you see down here, you need to add up the totals and successes, the errors and successes to actually get to the total first. So it's usually a better practice to just expose one counter for the errors as before, but then expose the total number of requests as a second counter. And now all your expressions with ratios will get much simpler. Another thing you might run into once you're starting to use metrics that are split up by one or multiple labels is that time series exposed from an instrumented service will only actually, get exposed or transferred to Prometheus once something has happened for a given label combination. So imagine this case here. We have a metric, ops total, tracking some number of operations happening in some server. And it has an op type label by which it is split up. And it could be 4 different operation types: create, read, update, delete, for example. And if none of these operations has happened yet, then no time series at all will be exposed for this metric yet, because the instrumentation client library has no idea what possible label values there could be, right? So this can lead to all kinds of issues. Imagine, right, you want to graph the total rate of operations in Grafana. You might write the sum rate of ops total over 5 minutes expression here. But the thing is, if no operation has happened yet, then this inner ops total selector will actually just return an empty result, which will cause the entire expression to return an empty result rather than a 0 rate, which might be unexpected. So your graph panel shows no data instead of a line at the value of 0. So that can be surprising. But if you base an alert on a similar kind of expression, then it's even worse, because an empty output, empty result of the PromQL expression in an alerting rule means that everything is fine. So now your alert will actually, silently fail, and that's not good. Similarly, maybe some operations have already happened, but you're querying for a specific one, like the create one in the second example here, then you get the same problem, right? If that one hasn't happened yet. So there's a couple of things you can do here. So in the first case, maybe you're lucky and there's only a few well-bounded possible values for that label. Then what you can do at the beginning, when your instrumented program starts, you can actually just reference each of the possible label values once on this overall ops metric here. So this is a Go-based example. You can just reference that child metric with a specific label value, and then it automatically starts to appear in the instrumentation with a default value of 0. And from there on, when you actually start incrementing it the next time, then it will go up from the 0. You don't have that problem at all if you have a metric that is not split up by labels, in which case it will automatically be there from the beginning of the program with a value of 0. So that's fine for these kind of very small, well-bounded cases. But what if you have cases where that's just not so feasible? The most prominent one is HTTP status code tracking, where you have a status label, and you probably don't want to pre-create all possible HTTP status code label values that could occur in your app, right? You would create a lot of time series that might never really get incremented. So, either you can just be aware of this and kind of be fine with your graph panels being empty or stuff like that. Or if you always want to default to a 0 in that case, you can use the OR binary operator. It's a set operator in PromQL to join in a metric that is always present for the same job that you're getting these metrics from that are currently missing, to join in a default value. And you have this multiplication by 0 at the end there to force it to a 0 value. This uptime series is always present for a job that you're scraping, or at least it should be. There is a blog post linked down here as well, which goes into more details on that whole thing. Okay, let's get to alerting. Once you've collected some of the data, you might want to be writing alerting rules, and there's a couple of things that are useful to know. First, a couple of general words. Again, if you have never written alerts, or at least in modern times, then there's this great Google doc called My Philosophy on Alerting by Rob Evershock. It's pretty old by now, but has a still pretty popular. Just some of the main points are basically that you don't want to alert on all possible causes like memory usage, CPU usage, disk usage, load average, like all these kind of resource usage metrics of your hosts and so on. try to actually alert on-call people based on what matters to a user, right? Is the site down? Is the site slow? And so on, right? These SLI, SLO, SLA style signals. Except for cases where you know it's not affecting the user yet, but it most assuredly will in a given number of hours, right? You see that the disk is running full. Generally, try to err on the side of fewer pages rather than more, just to not overload the on-call person, make them kind of just ignore pages. But you still want to collect all these other metrics as well, right? Your CPU usage, memory usage, and so on, just to be able to use them as a potential diagnosing tool once something is broken. All right, more Prometheus specific once again. Let's talk about a couple of Prometheus alerting gotchas here. So imagine you collect a metric from some targets here. It's called errors total. It's some kind of error rate, and you want to alert when this error rate is larger than 10 per second. This could be a fine alerting rule in your Prometheus server. It even has some kind of for duration in there to make sure it doesn't fire immediately, but only after 5 minutes and so on. But have you thought about what happens if Prometheus either tries to scrape the targets where this metric is supposed to be coming from, or isn't even trying? In both cases, your errors total metric would not be present. This selector for it would create an empty result, causing the entire alert to silently fail, because there's just no data at all there for that metric. So you want to be able to catch those situations as well. So in general, I recommend to have 2 types of alerts for each job or service that you monitor with Prometheus. The first one is you want to detect if Prometheus is trying to scrape a set of targets, usually grouped within a job, but cannot. Every time Prometheus attempts a scrape, it writes out a sample, a synthetic sample automatically into its TSDB with a metric name up and the labels of the target that it just scraped. And it sets the value of the up metric to 0 if the scrape failed and to 1 if the scrape succeeded. So with that, you can easily check, kind of do very, cheap health monitoring of whether these scrapes are succeeding or not. So you'll want to have one alert that is somehow based on this up metric per job. You could either, as in this example, alert on any individual target being down, or you could have aggregations around it or other constructs that alert you if a certain subset is down or you don't have enough up targets or so. But having some kind of alert based on the value of the up metric. The second type of alert you will want to have in case your Prometheus server isn't even attempting to scrape. For example, your service discovery mechanism might be having a bad day and it's not returning any targets for your job, or there's just a naming misconfiguration or a scrape loop is got stuck or so. For some reason, it's not doing these scrapes for the job. Then this metric that you're initially in this previous slide here that you are trying to alert on will also not exist. So there's this absent function in PromQL that can help you detect that. You basically put in some expression into the absent function, and if that expression returns an empty result, then the absent function will invert that empty result and return you a single element output vector, which makes this alert actually fire. So yeah, would just recommend you to have both of these types of alerts. In alerting rules, you can have one YAML field called the for duration that tells the alerting rule for how long the condition needs to be true until it transitions from a pending alert to a firing alert. And consider this alerting rule example here, where we want to alert if a single instance is currently not scrapable or down. What would happen here without any for duration is that a single failed scrape would immediately alert you. And that can happen so quickly, right? Like one short network blip or the instance is currently restarting and that takes 2 seconds or so. you typically want to add some amount of tolerance in there. So, add a for duration here of at least a couple of minutes to make that more robust. Second example, you might want to have exactly that kind of absent alert that we looked at previously. You can run into a similar issue here. Not typically with a Prometheus server that has recently scraped this metric, but what if the Prometheus server is completely fresh or hasn't been up for a while? Then this up metric selector here will be empty again, and you will get immediately alerted, right? If this alerting rule runs before the Prometheus server that is fresh can actually scrape those targets. So even in this case, you will want to add some kind of for duration. And this is true for pretty much almost all alerting expressions you can write, even the ones that have a rate with some time window already in the alerting expression. Because again, that could be a fresh Prometheus server where it's not really computing the rate over 5 minutes or so as provided in the expression, because there is not 5 minutes of data yet. So even there, it can make sense to have these for durations. So in general, make this at least 5 minutes. Could be a little bit shorter, of course, when you want to have faster responses, but don't omit it completely. Also, in alerting rules, often you don't want to alert on individual single highly dimensional time series, like one instance being down or so. Often you want to aggregate, like you want to say, alert me if the total error rate is too high or so. So what we see often is that people use a sum aggregator, or could also be a different type of aggregator, to just wrap the entire expression they want to alert on. And that gets rid of all labels unless you explicitly keep some labels. And there might be in this inner expression here with a rate, there might be many labels that are actually very common to all of the series within that sum, but those would get thrown away as well. And then when that alert reaches Alert Manager, it will have way less metadata than it could have. And you want to preserve as many labels as possible to make those alerts more useful in routing and grouping in the Alert Manager, to be able to silence by those labels, to be able to put them in alert templates of notifications. And so the least thing you would the very least thing you typically want to do is preserve the job label. So use this by job clause here. Could be a different label depending on your Prometheus setup, but usually the job label is the one that you kind of use as a namespace for your particular service that the metrics gets pulled from. Or even better, instead of the by modifier, use the without modifier, which throws away only the labels that you explicitly list. So this would preserve all the common other target labels and so on, and that's going to be really helpful on the Alert Manager side. All right, on to general querying. When you select data in these inner selectors that we already saw a bunch of, you can write a naked metric name, like in this don't example here, but you want to make sure that you're really selecting only the intended metrics. And the metric name itself actually doesn't have built-in semantic hard meaning, right? And it could be that even if today this is only selecting the data that you're intending to, tomorrow a different service run by a different team is monitored by the same Prometheus server, and they're using the same metric name, and you don't actually intend to also monitor that one. So you want to make sure that you avoid these collisions by always including some kind of selector in the curly braces here that namespaces your metric selection clearly to the set of targets that you actually intend to monitor. Again, in most cases, this would be the job label. Another thing, so PromQL has a set of functions, rate, irate, and increase, that tell you how fast counter metrics are going up in different ways. And these only work properly with counter metrics, but if you put a gauge metric in there, it will work, but it will give you a wrong result. Like there will not be an error, but you will just get back something nonsensical. So you have to be kind of careful here. right? A gauge metric is something that can naturally go up or down, like memory usage or disk usage, whereas a counter metric semantically means it's a metric that is a cumulative count of things over time, which naturally never goes down. The only time that counters can go down are when they're reset back to 0, which happens when the target that tracks the counter restarts, right? The process that is instrumented restarts and now it just starts again at 0. And to accommodate for these occasional resets, these counter-specific functions have reset detection, right? They detect if the value goes down under their rate window and they try to neutralize that away. And they will always only give you a positive result. So if you put memory usage into the rate function and it's currently going down, the rate function will happily just think, oh, well, that's a counter reset, and it will just return something positive anyway. So be careful with that. And vice versa, there are two functions here, deriv and predict linear, which are kind of the pendant for the gauges. And these only work with gauges, not with counters, right? Because they can actually return negative rates of increase or decrease. And they do not have any concepts of counter, reset, detection, and correction. So you would get incorrect results for counters with these. So there is no error here, but you just need to be aware of this and be careful. When you are calculating rates of increase, whether that's actually with these normal counter rates or the gauge derivatives, you want to make sure that these functions actually see at least 2 samples under the provided windows. You know that in square brackets 5m part or so. That needs to cover at least 2 scraped samples of a series in order to even calculate the delta and the difference, right? And so what can happen is if this rate window that you write in your query is too small, you might, it might cover something where there was a bad scrape, and then it only will cover a single sample, and then it will output nothing for that particular resolution step. At least there will either be a gap in your graph, or in a tabular view the series will not show up at that point in time. So if you want robust rates, you typically want to choose your rate window to be at least 4 times your scrape interval, so you can also tolerate bad scrapes, unlucky window alignments with the actual physical samples that exist, and so on. So try to keep your rate windows at least 4 times the scrape interval. Last section here, let's talk about monitoring topology, especially exporters. There's this big question of, between all the things that you monitor and the Prometheus server, does it make sense to first put everything into one big aggregator, like one big exporter where all the data from the different things gets kind of staged, and then Prometheus only needs to pull from that one thing? Or is it better if Prometheus can directly go out to all your different targets and scrape them directly? So in the first case here, imagine you have, let's say, a host, and everything on that one host or machine gets sent to a single exporter on that machine first. So you have a web application, MySQL database, host metrics, container metrics, all kinds of wildly different things, potentially even owned by different teams, all put into this machine exporter, and Prometheus only needs to pull from that. So on the pro side, you might think, hey, that's great. Prometheus only needs to pull from a single endpoint. That keeps my Prometheus architecture pretty simple. But it has a bunch of downsides in the Prometheus philosophy. So first of all, it's a bit of an operational bottleneck. All the different teams running the different stuff on that host now need to talk to each other, and they kind of might step on each other's toes. This exporter doesn't isolate these different service metrics properly from each other. It's a single point of failure. If you're running multiple Prometheus servers and you want to, maybe one is run by one team, the other one's run by a different team, and one team wants only the web app metrics and the other one wants the MySQL metrics, then they have to, the configuration for the selective scraping of metrics now becomes harder, because you can't just scrape them individually directly. And we talked about this up metric previously, where Prometheus automatically writes the up metric with a value of 0 or 1 for every target that's being monitored. Now it will only do that a single time for the exporter as a whole. And if you want to know if anything behind the exporter is up, so to say, you have to now manually track that in different ways and associate the metadata correctly, right? So that gets more complicated. And yeah, normally when Prometheus scrapes a target, it will also have a lot of labeled metadata about the target from the service discovery mechanism, like this is a so-and-so host with a given role, or on Kubernetes, this is a metric for the following pod and namespace, and those labels will automatically get attached to that, to all the time series in that scrape, and all that breaks down in this case as well. So usually much better to go to this model where Prometheus can directly go to your apps that are either directly instrumented with a Prometheus client library, or where there's an exporter sitting next to them, like one exporter per process sitting next to them that Prometheus can directly scrape to. So you have these very fine granular scrapes, and you get rid of all these downsides that I mentioned, right? So especially, every scrape now assigns proper metadata and health data with this up metric. All right, so there's a similar problem when you try to abuse the push gateway, which is another Prometheus component for monitoring batch jobs mainly. When you abuse that for trying to convert Prometheus into a general push-based monitoring system. But I have more details under this link to the Prometheus docs here. All right, so yeah, I'll hand it over to George for the Chronosphere part.
Thanks, Julius. Had trouble finding my mute button there. So thank you very much. This, Julius gave some really detailed tips for, managing your Prometheus. Really detailed, really excellent stuff. The majority of Chronosphere customers today manage Prometheus themselves before using Chronosphere. And so from talking to our customers, they've shared kind of 4 big signs to look for that they were kind of reaching the end of their ability to manage Prometheus themselves on premises in the cloud, trying to manage it themselves with their staff just got more difficult. And we've had some customer comments come up, and I think it was DoorDash that basically said, we didn't hire all these engineers to manage our observability platform. They should be doing other things that are more productive. And so we have a detailed webinar that we did a couple months back called 4 Signs It's Time to Up-Level Your Prometheus. And you can access it on the Chronosphere website. And I think a slide coming up actually has a link to it, which I think is a really more thorough, more detailed look at the signs that it's time to maybe look at a managed service for Prometheus. But I just kind of wanted to touch on these things here at a real high level. When you're trying to incorporate all the great tips that Julius just went over, if you have a managed service, it actually can be easier to implement some of those things. So if you're experiencing these things, it's important to act, before a customer gets impacted. And we've had the occasion where we've worked with a potential customer, and they've kind of delayed making a decision to use a managed service. And then a couple months later, they come back and like, okay, we need to get to a trial right away because we just had an instance that actually affected our customers, and it was a really big deal. You want to avoid those things from happening. But we are a very reactive society in general, where we kind of wait for something really bad to happen before we decide to fix it. But look for these signs, because these are signs that something on the horizon bad could happen, and you want to act before it affects your customers, or one of your best engineers just quits because they're sick of doing all the firefighting. And the first thing to think about and to look for is when you start hearing complaints from engineers that they can't locate observability data quickly. When you scale Prometheus, to scale it, you need to spin up separate Prom instances and have each instance store and scrape data from specific services. And this will manually shard the load across your Prom instances. And this can cause problems as you scale. From a dashboarding and alerting perspective, you need to tell each dashboard or alert, which node or Prom instance to point to get the data. You also may have a single dashboard or alert that needs data from multiple Prom instances. And so you federate instances and create a subset of data for the original instances. And there's more we cover in that webinar, but the bottom line is that you're scaling Prometheus leads to more federated nodes, which leads you to having a much more complicated prom structure. And as you do this across zones and regions, you need to federate the data in another prom instance, and combine that across both zones or regions. So you need to remember which prom instance contains the data that you're looking for. And you'll likely hear from engineers that it just takes too long to find the data and run queries and fix issues. The second thing you look for is when you're beginning to lose observability data. So out of the box, Prometheus does have a significant point of failure. So if it goes down, you can lose active data and access to also historical data. So it's always recommended to multiple instances that both scrape the same endpoints. One goes down, you still have a copy of your metrics. And you'd run load balancers and point your Grafana instance to the load balancer. This generally works for reliability in the sense that you get one copy of the data. The problem is that if you're doing rolling restarts of your prom instances, then you'll come across a gap in your data as the prom instance is down and restarting. And again, the bottom line is you may need a longer term storage solution or remote storage solution, or perhaps distribute across multiple cloud regions and cloud providers to get that fault tolerance. And again, it adds more complexity. And the third thing that you need to be aware of is that when teams need to retain more data for longer periods of time, Prometheus is not super efficient for long-term data. There are no built-in downsampling capabilities. So for example, if you're storing data for 6 months, a scrape interval of 30 seconds, it ends up being around 8 kilobits per second. But if you're able to downsample to 1 hour resolution for 6 months, it would only use up around 68 kilobits per second. So as you store more and more longer term data, downsampling becomes very valuable for efficiency. So again, there's some workarounds, but again, it adds another layer of complexity and engineering time to manage the Prometheus environment. And fourth, I think a very clear sign that you're bumping up against the limits of managing this yourself is you're being forced to make difficult data collection versus cost trade-offs. In a perfect world, we can capture everything, so we always have the data that you need. But in practical terms, the sheer volume of observability data as you transition from cloud to cloud native, it's increasing at a faster rate than your production environment. We've actually had customers we've worked with where the costs of their observability platform were higher than their production environment when they got to a certain scale. And if it makes sense. If you're running on a VM and now you're running containers, your infrastructure and cloud bill can be pretty close to the same with the same cluster size, but instead of tens of VMs, you're now running hundreds or thousands of containers, each of which is generating the same amount of telemetry data as the VMs. So your observability costs end up higher than the infrastructure supporting your apps. And so if you're reducing monitoring as you move to containerized applications, to keep costs down, it's likely time to do, look for a more scalable solution for that. So in the next slide, Julius. So a little bit about Chronosphere. It is a single platform managed service for cloud native observability, incorporating metric, trace, and event data. So it is purely a SaaS solution. Actually, the only thing that you have to manage in the environment, I think, is just you have to deploy, manage your collectors, but everything else is provided as a managed service. And it's more than just logs, traces, metrics. We hear the 3 pillars all the time, right? And anybody can add support for all these different data sources, but that's what they are. It's better to focus on the outcomes, right? How fast do you know that there's a problem? How quickly can you triage it and then be able to understand and get to root cause? And the real unique feature of Chronosphere, though, is the control plane at the center of this graphic. And this helps central observability teams really get that data growth under control while improving your key metrics. Our customers have reported 50% less time troubleshooting issues because they can get to the data faster. And on average, Chronosphere customers have reduced the amount of data by 48%, but while improving their key metrics. That's an important aspect. Anybody can just cut data, but then you create blind spots. What Chronosphere is able to do is to actually make sure that you're getting the right data so that you can respond to issues much more quickly. And the way we do that with the control plane, again, is being able to combine, downsample, aggregate metrics, add, drop, change labels on metrics, adjust retention and resolution, and we transform that data. It's about really shaping the data so that you're getting the right data to be able to troubleshoot issues faster. And it's transformed inline before we store it. So you're not paying for just ingest, we're only for ingest and then paying for storage, which is unique. Most solutions in the market will charge you for ingest and then charge you for storage. We only charge you for the data that actually gets transformed and stored into the platform. And lastly, we do also offer full support for Prometheus recording rules as well. And a note about reliability, because there's a lot of SLAs, a lot of companies will actually offer SLAs. You have to dig into their websites and look at what their actual results are. And most of them do publish what their outages are and what their uptime has been. And it's great to be promised an SLA. But when you have a credit at the end of the month for the system being down is small consolation when you have customers impacted by an outage. So we historically have delivered 4 nines. Our SLA is 3 nines, and we've historically delivered 4 nines. And so a lot of times customers, if they have, they'll have their observability platform go down because it's hosted in the same area as their production apps. So now I have no apps and I have no visibility into them. So I think that's a big thing that a lot of our customers have given us feedback on, is like the reliability of the observability platform becomes a big deal. On the next slide. Thanks, Julius. So really at a high level, one of the benefits of working with Chronosphere, and this has directly come from our customers, right? It's getting control over your observability data. You decide what is kept, for how long, and at what resolution, and we give you a lot of tools to be able to manage that. So you can see all of the metrics each team is producing, set quotas and limits by team, fully open source compatible, but with a much better end user experience. And there are some hidden costs in running this yourself that we really help to fix for you. So some of the impact on that our customers have experienced. So Robinhood, one of our customers, their mean time to repair went from 2 minutes to 30 seconds. And when you're in a regulated industry where downtime can mean fines, sanctions from the SEC, like every second there counts. Abnormal Security used to run their observability in-house, and it just became too time-consuming to manage. And so they started looking at SaaS vendors. And because of our aggregation capabilities, with Chronosphere, they were 10 times more cost-effective than the other solutions that they looked at. What's more is that after becoming customers, they saw a real surge in their business growth on an order of magnitude of 20x, but their monitoring bill only rose 4x. In DoorDash, they had used a different observability solution that suffered from downtime, they had data loss, and at the scale they were operating at. So since coming to Chronosphere, DoorDash's business has grown 4x, but we still maintain the highest SLA that I showed earlier, even at their data volume, which is as high as 20 million unique time series per second. And I think that was it, Julius. We'll go to the next slide, and I think we're also gonna oh, that's right, very important. we announced this recently at KubeCon, that Chronosphere, together with Prom Labs and Julius, have donated Prom Lens to the Prometheus organization as open source software. So very exciting, really trying to facilitate more adoption of Prometheus and make it easier for people to get started, to write their queries. Some of the moving to open source can be a bit challenging. Some complexity will hold that back. And so we're really trying to make the query building accessible to both newer engineers as well as experienced engineers. Anything else you'd like to add to that, Julius, as well?
Also needed to find the mute button. Yeah, no, I'm super excited about this. So Prom Lens, I originally built as a commercial tool with Prom Labs. End user customers bought it. Chronosphere also integrated it into their platform as a PromQL query builder and analyzer last year. But now it's so great. Like, Chronosphere and Promlabs jointly releasing this as open source to the Prometheus project means that everyone can now actually, build PromQL queries way more effectively and with less frustration. So I'm really happy about this. Thank you.
Yeah, really exciting news. And there's blogs both in Julius's Promlabs site as well as on the Chronosphere site that get into a little bit more detail on the announcement that we made. So in the next slide, which I think just kind of wraps up. Yeah, so these are some resources, and I believe the deck will be shared afterwards, so don't worry if you can't click on the link here. Actually, on YouTube, there's the Prometheus documentary, which was, again, released at KubeCon. Really cool. It tells the whole story of where Prometheus came from. And I thought that was a really cool documentary to see its humble beginnings and what it's kind of turned into. It's very cool. Definitely read the case studies on our website. Again, I mentioned that the 4 signs to level up your Prometheus, both the webinar and also there's a quick sheet on our site that you can go check out, and a buyer's guide too. And definitely we can schedule a conversation with Chronosphere, set you up with a trial, things like that. So definitely check that out as well. And I think from there we just go to the Q&A if we have questions that have come through.
All right, yeah, thanks guys. A lot of good detailed stuff there. Always happy to see that. We like to give our developers and our audience as much value as possible, so we really appreciate that, guys. Looks like we did have a couple of questions come in our last few minutes. Let me see here. This is definitely gonna be for Julius, so here you go. Given that it's easy to run into time series cardinality issues with Prometheus, how do you protect against these, especially with diverse teams?
Right, yeah, so as I mentioned, this can happen very easily and quickly. Just one developer needs to have the smart idea to put something very unbounded into one label value, and then your existing Prometheus server is already scraping metrics from that target, and it will get overloaded. So there's a couple of things, like there's not the one silver bullet, but there's a couple of things you can try to do here. First of all, always try to fix the instrumentation. So find out where the metric is coming from. Think hard about whether you need that label, and whether you maybe, even if you need that label, maybe you can pre-process the values that get put into it to condense them down into categories rather than full detail or so, right? To just reduce the cardinality a bit there. You could potentially also remove them completely. Often the culprit are histograms that are split up by too many different buckets. So there, sometimes there's an option to reduce the bucket resolution. There is a new type of native histogram that has just been being added to Prometheus right now. It's still experimental, not an official feature yet, but this will make histogram usage both easier and way more efficient in Prometheus. So in a couple of months, that should be stable enough for the general population to use it. But that's really exciting. Absent a fix in the instrumentation, you can also have some mitigation in the Prometheus server itself. So when you're scraping a target, you can configure a max samples limit as well. It's called a sample limit in the scrape configuration. And so whenever a single scrape returns more than a given number of time series, that entire scrape fails. So that will not help you actually get the metrics into your Prometheus server, but at least it will, that one target that is behaving badly will not kill everyone else as well. You could also have metric relabeling rules in your Prometheus server that throw away parts, like certain metrics with a given metric name, where they produce too many metrics. And yeah, if all that doesn't work, right, maybe you just need more resources. You might want to go to a more scalable system. So these are some that you can run yourself: Cortex, Mimir, Thanos. Or if you go to something like Chronosphere, not only do they handle the scalability part for you, but they have this, I think, as George mentioned, what I find really cool is this way to detect which metrics are like the highest cardinality on ingestion, and then allow you to configure aggregation rules in the ingestion layer for summarizing and aggregating over some very high cardinality data. So you don't actually need to ingest all of that. So yeah, those are like a couple of different options in different places of the system of where you can attack this.
Cool. All right, good to know. Okay, looks like we got one more question here. How can you monitor for cardinality explosions?
So in general, there's one key metric in the Prometheus server that just tells you how many time series this Prometheus server is currently tracking within its head time series database block, which spans the last couple of hours. It's called Prometheus TSDB samples appended total or something like that. And no, that's the total number of samples. I'm thinking of Prometheus TSDB head samples total. I think that's the name. And that head series total. And that is just the number of these currently indexed series in the head block. And just having a look at that is always a good, good thing. So, tracking if that just goes absurdly high, at least is a good thing. Other than that, the Prometheus server has a number of status pages. One of them is the TSDB status page in the web interface that, as long as the Prometheus server hasn't exploded yet and is still running, can tell you which your most expensive metrics actually are. So there it tells you like for every the top 10 label cardinalities and things like that. So that can be useful. There's also a number of PromQL queries you can write to kind of get an overview of which are my combinations of target and metric name, for example, that have the highest time series count or so. I think if you search in the Prom Labs blog for exploring metrics or so, I have some queries of that type in there.
All right, thank you for that. All right, so I don't think we have any more questions at the moment, but if anyone does have any further questions, you can feel free to contact Julius or George at the contact information you see on the screen here. Thank you so much, Julius and George, for joining us here today, guys. Really appreciate y'all being here. A lot of good stuff, like I said. And for everyone else watching, I encourage you to check out our website, dzone.com/webinars. We've got a ton of other great events just like this one. We've got past webinars, we've got on-demand webinars, and all kinds of upcoming events to check out. So visit dzone.com/webinars, and you can see everything we've got there. We cover a wide range of topics that are relevant and important for developers, so check it out. Thank you everyone so much for joining us today. We really appreciate you being here. Have a wonderful rest of your week, and we'll see you next time.
Thanks.
Thank you.